In this lesson, you will learn how to simplify negative and zero exponents. So first, let's review the first three properties of exponents. The first property says that when you multiply two monomials together with the same base, that you add their powers. So if you had x to the third times x to the fifth, to simplify this, since you're multiplying, it would be x to the 3 plus 5, you add the exponents, and you would get x to the eighth. The same would be true if you were multiplying 2 to the third times 2 squared. When you multiply, you don't change the base, you only add the powers, so it's 2 to the 3 plus 2, which is 2 to the fifth, and 2 to the fifth we can evaluate by multiplying 2 by itself 5 times, so that we have 4 times 4 times 2, and 16 times 2 is 32. The second property of exponents states that when you're dividing monomials with the same base, the rule is to subtract the exponents, but starting with the highest exponent first. So as an example, if we had x to the 17th over x to the 15th, the higher exponent is in the numerator, so this would simplify to x to the 17 minus 15, which is x squared. Whereas if we had x to the 8th over x to the 14th, since the higher exponent is in the denominator, it would be 1 over x to the 14 minus 8. And so the final answer would be 1 over x to the 6th. Another example would be 2 to the 8th over 2 to the 5th. And if you subtract the exponents starting with the larger one, 8's in the numerator, so the difference would be in the numerator. We get 2 to the third, and 2 to the third can be evaluated. 2 to the third is equal to 8. If we had 3 to the 11th over 3 to the 13th, we still subtract the exponents because we're dividing, but we subtract the 11 from the 13, and since the 13 is a larger number and it's in the denominator, it would be 1 over 3 to the 13 minus 11, which is 1 over 3 squared, and that gives us 1/9. And property 3 states that when you have a power raised to another power, the rule is to multiply. So if you had x to the third times, or 2 the 7th power, and for the third property, this is called the power rule. If you have a power raised to another power, the rule is to multiply. So if you had x to the third to the 7th, this power would get multiplied by the exponent inside, so it would be x to the 3 times 7, which is x to the 21st. If you had 2 to the third, and then a square on the outside, the 2 gets multiplied by the power, not by the base, and so you have 2 to the 3 times 2, which is 2 to the 6th, and 2 to the 6th can be evaluated. So that you have 16 times 4 is 64. So property 4 is a zero exponent, and the property states that anything raised to a power of 0 is equal to 1. So if you had 3 to the 0, 3 to the 0 is equal to 1. If you had x to the fifth times x to the negative fifth, when you multiply exponents, the rule is to add them. So you have x to the fifth plus negative 5. Adding them together gives you x to the 0. And again, anything to the 0 equals 1. If you had x to the third over x to the third, when you're dividing, you subtract. And if we take the top exponent minus the denominator, in this case it wouldn't matter because they're equal. 3 minus 3 is 0. And again, anything to the 0 equals 1. Another example is if you had 3 to the 17th raised to the 0. The 0 would multiply times the power, and that would be 3 to the 17 times 0, which is 3 to the 0. Anything to the 0 equals 1. And a last example is if you had 6 times xy to the 0. This whole quantity inside the parentheses is equal to 1. So the final answer here is 6 times 1, which is 6. So the 6 is on the outside, its power is 1, not 0. So only this quantity is equal to 1, and it gets multiplied by 6. And for property 5 has to do with negative exponents. So when your exponent is negative, the first thing you want to do is change it so that it's positive. And the rule is that when it's negative, you want to move where it is in the fraction. So if you have x to the negative m, x to the negative m is really over 1. So you want to move this to the denominator, and when you do that, you change it to positive. If you have a negative already in the denominator, you move it to the numerator, and when you do that, you change it to a positive. If you have a negative in both the numerator and the numerator will move to the denominator and then become positive. The denominator will move to the numerator and also become positive. So one example is if you had 3x to the negative 2. So I'm going to put this over 1, and I'm going to move just my x term to the denominator. The 3 has a positive 1 as an exponent, so it stays in the numerator. And you would write that as 3 over x squared. If you had a to the negative fifth times a squared, I'm multiplying, so I would add the powers of negative 5 plus 2, which is a to the negative 3. And you never want to leave a final answer with a negative exponent. So I put this over 1, move the entire term to the denominator, and I would write the final answer as 1 over a cubed. If you had x to the 7th over x to the 5th times x to the negative 8th, the only exponent that's negative is this last one right here, the x to the negative 8th. So I'm only going to move this one up to the numerator and rewrite this as x to the 7th times x to the positive 8. You're moving it to the numerator, so the sign changes, but everything else stays the same. And combining properties here, if I multiply the numerator together, the rule is to add the exponents. So that I get x to the 15th over x to the 5th, and then I subtract the exponents to get a final answer of x to the 10th. So now let's look at some examples that you might see in your homework that involve all the different properties of exponents. And the directions are to simplify and write each expression using positive exponents. Sometimes the directions will just say simplify. If it only says simplify, you have to know to still write your expression with positive exponents. So for number 1, we have 10 to the negative 8th over 10 to the negative 6th. The first thing I want to do is always change my exponents to a positive number. So the 10 to the negative 8th is going to move to the denominator and change the negative 8 to a positive 8. The 10 to the negative 6 is going to move to the numerator, and the negative 6 will now become positive 6. So I'm changing this fraction to 10 to the 6th over 10 to the 8th. Once I have the exponents positive, now I would just use one of the other properties. And the property that I would use involves division. When you're dividing, the rule is to subtract the exponents, starting with the higher power, which is 8. It's in the denominator, so it's 1 over 10 to the 8 minus 6, which is 1 over 10 squared. And 10 squared is 10 times 10. So the final answer is 1 over 100. For number 2, 15 to the negative 3rd over 15 to the 7th. Only the numerator has a negative exponent, so the 15 to the 7th will stay in the denominator. I'm only going to move the numerator to the denominator and write it as 1 over 15 to the 7th times 15 to the 3rd. And now I'm multiplying the terms together. So the rule is to add the powers, and I get 1 over 15 to the 10th. So since this number is very large, I'm just going to leave this as 15 to the 10th, rather than expand out 15 times itself 10 times. For number 3, 12x to the 8th over x to the negative 2. Again, first step is to change the negative to a positive, so I bring it up, and I have 12x to the 8th times x squared. We're multiplying, so the rule is to add the powers, 8 plus 2, and so my final answer is 12x to the 10th. For number 4, we have 6 times 6 to the negative 4. And I'm just going to rewrite this first as 6 to the 1st times 6 to the negative 4. And then I want to take this whole fraction, or write it as a fraction, put it over 1, and then only take the negative 4, move it to the denominator, so that I have 6 to the 1st over 6 to the 4th. The only part that moves is the one that has a negative exponent. Everything else stays where it is. And now I would use one of the other properties. Property 2, we're dividing, so we subtract the exponents, starting with the denominator because the larger exponent is in the denominator. And we get 1 over 6 to the 3rd. And this one is small enough to where we could figure it out. 6 times 6 times 6 is 36 times 6, which is 216. So the final answer is 1 over 216. And for number 5, 5 times 8 to the 0 times 12 a to the 7th. So I'm first going to write out this problem. 5 times 8 to the 0 times 12 a to the 7th. Property 4 says that any base raised to a power of 0 is equal to 1. Be very careful that you don't eliminate the 5. 5's power is 1. It's only a's power that is 0. So we have 5 times 1 times 12 times a to the 7th. And if I multiply 5 times 1 times 12, I get a final answer of 60 a to the 7th.